Hey, this is Mr. Molo for lesson 4-4, scatter plots and lines of fit. So this is going to be a little bit shorter of a lesson. There's not a lot in this lesson. So a scatter plot is pretty much what it sounds like. It's a plot of scattered points. So you probably see these sometimes in science when they're talking about things like rainfall and things like that. It's not going to be an exact line. You're going to have dots scattered throughout the graph. So a couple of things that we need to do today. Same thing, dots are scattered. We're talking about ages. It's not going to be a straight line there. You're going to have dots scattered across the graph. So a couple things we need to talk about before we get there. So scatter plot I just went over. Correlation. So correlation is how the plot looks and if you can predict what's going to happen. And we got three kinds of correlations. We have positive, we have negative, and we have no correlation. Okay. And these might be a little confusing, especially when they get put into words. On a graph, they're a little easier to see, but when you get them as a word problem, it might be a little more confusing. Positive just means that your numbers are going up. It doesn't necessarily have to mean something positive or something good is happening. It just means that the numbers are going up. So like the more cigarettes you smoke, the more likely you are to get cancer. Both things are going up. The more cigarettes you're smoking, the more likely you are to get cancer. Okay, those things aren't positive, they're not good, but the correlation there is positive. One thing goes up to make the other thing go up. The same thing goes for negative. Negative isn't necessarily always a bad thing for correlation. Okay, it means something is going to go up to make the other thing go down. The more you work out, the less you're going to weigh. So the more you work out 5 minutes a day, 10 minutes a day, 100 minutes a day, then your weight is going to go down. Okay, so something is positive to make the other thing go negative. And then no correlation is just something that aren't related, like whatever, the color of your shoes and your grade in math. Like just because you have blue shoes on right now doesn't mean you're getting a B in math or something. So those are things that are kind of then unrelated. So it might be a little more confusing for the word problems. It's a lot easier to see when we're actually looking at a graph. But you might get some problems that are word problems and they might ask you, is it positive, negative, or no? And people have a hard time getting the positive has to be something good and negative has to be something bad. It's not like that. Just if the numbers are going up, then they're both positive, then or both going up, then it's positive. If something is going up to make the other thing go down, then it's negative. If they're completely unrelated, then it's no correlation. Okay, this first one's going to make us read this graph here. So the scatter plot shows the weight in pounds of a baby over time. Okay, what is the weight of the baby when the baby is 4 months old? So very important that we're looking at the labels here. So this vertical has weight and the horizontal has age. So we're looking at 4 months old. And if I follow my 4 months old up here, looks like it's just under 14 pounds. So I'm going to say 13.9 pounds. Okay. Now next one has us looking at the age. What is the age of the baby when it weighs 17.2 pounds? So here's 16, here's 18. So I'm looking for one that's 17.2. So that one right there. And so at 17.2, if I follow that down, that's going to be about 8 months. Okay. And then here, what tends to happen to the weight of the baby as the age increases? So as the age increases, as this baby's getting older, then the weight also will increase. So this would be one that's a positive correlation. The weight goes up, the age goes up, or the age goes up and the weight goes up. So that is a positive correlation. Both things are going up. All right. Here, 2, 3, 4, 5. Want us to say pretty much what I talked about before. Is it a positive, is it a negative, or is it a no correlation? And these should be a little simpler because there's no words there. We're just looking at the graph and we're talking about most of the dots. There's always going to be an outlier on there, that one random dot that doesn't mean anything. But when we're talking about the correlation, we're talking about most of the dots. And remember, from left to right, if it goes like that, left to right, that is a positive correlation. From left to right, if it goes down, then that is a negative correlation. So looking at number 2, from left to right, it looks like most of these dots are trending upward. So this would be a positive correlation. Most of those dots are going up. If you look at number 3 here, it looks like most of these dots from left to right are heading in the downward direction. So this would be a negative correlation. Okay. Number 4, it looks like they're kind of spread out all over the place. There's some dots over here, dots over here, dots over here. You can't really predict what's going to happen next. So this would be one of those that is a no correlation. And then number 5, again, it looks like most of the dots are trending upward. So this is going to be another one that has a positive correlation. All right, number 6. This is a part of the video where you might want to watch it more than one time. Might get a little complicated. So the table shows the depth in centimeters of the water filling the bathtub after X minutes. So we have our X's 0, 2, 4, 6, 8, 10, 12, and then we have our depth, our amount of water in centimeters, 6, 8, 11, 14, 17, 20, 24. And as we look here, we can see our time is constant. It's going up by 2, but we can see our Y is not constant. This time it goes up 2, this time it goes up 3, 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 and this time it goes up 4. So it's not really constant. So most of the time we would say like, oh, well, we can't do this because it's not constant. But we can. We pretty much are taking the average of all the slopes. And that's a lot of math if we have to do that in our head. Okay, so if we're saying that it's the average of all the slopes, we're going to actually use our graphing calculators to figure out what the average of all the slopes are. Okay, so in Schoology, I have a link there for you for a graphing calculator. Okay, so pretending you're taking the MCAs here. So there's no question, but there is a calculator there for you to use. Okay, so I'm going to press this list stat button right here, and I'm going to edit my list. And it gives me all these columns, list 1, list 2, list 3, list 4, list 5. Okay, since we're in 9th grade math, we only have 2 lists. When you get something in Algebra 2 or Calculus, you might have like 7 lists or something. So we have a list of X's and we have a list of Y's. And so I'm going to just put these in to the calculator. I'm going to put all the X's in my list 1. So 0, 2, 4, 6, 8, 10, and 12. So I just, 12. There we go. Okay, so I put all the X's that were on this list right here. 0, 2, 4, 6, 8, 10, 12. Okay, now I'm going to put the Y's in there in list 2. So I have 6, 8, 11, 14, 17, 20, and 24. Okay, notice how all of these are lined up. My first point is 0, 6, then 2, 8, then 4, 11, just like it is on here. 0, 6, 2, 8, 4, 11. It's very important that they're lined up, otherwise then that messes with your data. Okay, so all my X's went in list 1, all my Y's went in list 2. Then I'm going to press this stat button again, except this time I'm not going to go into this edit mode. I'm going to use my right arrow on my calculator. I'm going to slide over to calc. So do you see how that highlighted black went from calc over there? Now it went over to test. So if I push it to the right, it goes to the right. Push it to the left, it goes to the left. And I'm going to go down here to number 4, the linear regression. So this is going to give us our linear formula. And it even asks us, yep, X's are list 1, Y's are list 2. So yep, we're good. So I'm going to go here, calculator, do the work for me, and I want it to calculate. So it tells me, and for some reason the calculator doesn't use y equals mx plus b, it uses y equals ax plus b, but kind of the same thing there. So y equals ax plus b, and it tells me that a is 1.5. So that means my slope is 1.5, and my y-intercept b is 5.28. Okay, this one doesn't, on the problem, doesn't tell us to round. The ones on your homework will tell you to round to the nearest hundredth or tenth. So I'm going to write the equation. 1 equals 1.5x plus 5.28. Okay, so my slope is 1.5. My y-intercept is 5.28, just like it is from here. So y equals 1.5x plus 5.28. So interpret the slope and y-intercept. So this means it fills up, the bathtub fills up at about 1.5 gallons per minute. And it looks like there was about 5.28, or not gallons, sorry, we're talking about centimeters. 1.5 centimeters per minute. And there was 5.28 centimeters of water when we started the bathtub. Okay, so kind of the same thing as our slope and y-intercept. Slope, the thing that happens every minute, every hour, every whatever we're talking about, and then our y-intercept is our starting point.